Every year in the United States, millions of avocados are harvested not to be eaten fresh. They are grown, cared for, and processed to become avocado oil, a product found in kitchens across millions of American homes. Behind a bottle of avocado oil that looks simple is a massive operational system, where nature, human labor, and technology intersect. This is a process that unfolds over months, yet is decided hour by hour, step by step, from the orchard to the factory. Before there are factories, before there are automated lines, everything begins with biology. Avocado trees bloom for only a short window of time. Pollination depends entirely on bees, wind, and weather conditions. Once pollination succeeds, it takes many months for an avocado to fully develop. There is no technology that can shorten this phase. In agriculture, biological time is still irreplaceable. When harvest season begins, the most important factor isn't speed, it's precision. At avocado farms across the United States, most avocados are still harvested by hand, one fruit at a time. There are no falling avocados, no violent shaking to force fruit off the trees. Because with avocados, even a minor impact can affect internal quality. Workers enter the orchards early in the morning, when temperatures are low and the fruit hasn't absorbed excess heat. They carry ladders, harvest bags, and most importantly, experience built over many seasons. Each avocado is picked with a familiar motion, a gentle grip, a twist at the stem, and a clean, controlled release from the branch. The fruit is never pulled, never dropped, never pressed against hard surfaces. Avocados may look tough on the outside, but the flesh inside is extremely sensitive. A small bruise may not be visible immediately, but within hours or days, it can become an oxidation point. For avocados destined for oil production, this is especially critical. Any early fermentation can alter flavor and reduce oil stability. Skilled harvesters don't need test cuts or instruments. They assess ripeness through weight, skin texture, and the resistance felt at the stem. They know which fruit has reached optimal oil content and which ones need more time on the tree. Across orchards spanning hundreds of acres, this process repeats row by row, week after week. Despite modern agricultural technology, this remains one of the hardest stages to fully automate. Because at this point, decisions aren't based solely on data, they're based on judgment. Machines can measure size, color, weight, but evaluating an avocado in the context of its specific tree and growing conditions is something humans still do best. That's why manual harvesting isn't outdated. It's the industry standard. And at this first step, the future quality of avocado oil is already being decided. As farm operations scale up, hand harvesting alone becomes a logistical challenge. Some avocado farms in the US span hundreds of acres. Harvest must happen within a narrow window to maintain consistent input quality. Here, technology isn't introduced to replace workers, but to support them. Self-propelled harvest platforms are one of the most common solutions. These mobile platforms move along orchard rows, lifting workers to the height of the canopy. Instead of climbing up and down ladders, workers stand on stable platforms, maintain proper posture, and focus entirely on fruit selection. What matters most is what happens immediately after the fruit is picked. Avocados don't fall into bins. They're placed directly onto padded conveyor belts running along the platform. These belts are engineered to minimize mechanical impact, soft surfaces, slow, consistent speeds. The goal is to preserve internal structure before the fruit reaches larger containers. With this setup, each worker can harvest more fruit per hour without sacrificing precision. Fatigue decreases, errors drop. But one thing remains unchanged. Technology makes no biological decisions. Machines don't determine ripeness. They don't assess oil content. They don't choose which fruit gets picked. All decisions remain human. Technology handles what doesn't require intuition: lifting, transport, and managing fruit flow after harvest. This reflects a broader philosophy in large-scale American agriculture. Not automation at any cost, but stability and control. In outdoor farming, where every tree grows differently and every season behaves unpredictably, human adaptability remains essential. The question isn't whether machines will replace people. It's how people can work best with the right level of technological support. At this stage of avocado harvesting, this balance works. Robotic avocado harvesters are no longer science fiction. Some farms and research centers are testing robotic systems equipped with high-resolution cameras, AI vision, and soft-grip robotic arms. In theory, robots can identify avocados, estimate size, and perform gentle picking motions. But real orchards are far more complex than laboratories. Avocado canopies are dense. Fruit is often hidden behind leaves and branches. No two trees grow the same way. Lighting changes constantly throughout the day. Wind causes branches to move. Avocados aren't always positioned where robots can easily reach them. Under these conditions, current robotic systems still face limitations. They operate slower than humans. They're expensive to deploy and maintain, and they lack the flexibility to handle unexpected scenarios. For now, robots aren't a viable solution for large-scale avocado harvesting. The U.S. avocado industry has chosen a pragmatic path. Humans make the final decisions. Machines assist where appropriate, because the newest technology isn't always the most effective. In agriculture, the best solution balances cost, quality, and long-term control. At the harvest stage, the human-machine partnership remains optimal. Once harvest is complete, time becomes the most critical variable. Avocados can't sit idle. From the moment they're removed from the tree, enzymatic activity and oxidation begin. On large farms, fruit is pre-sorted in the field and quickly loaded onto refrigerated trucks. Temperature is tightly controlled throughout transport to slow biochemical changes. A delay of just a few hours, or improper temperature management, can impact oil quality downstream. In avocado oil production, logistics isn't just transportation, it's a race against time, where every decision affects the final product. When truckloads of avocados arrive at the facility, a completely different phase begins. Here, avocados are no longer fruit, they are industrial raw material. Time remains critical. The goal is to convert avocados into oil under the most stable conditions possible. First comes intake and washing. Avocados move onto large conveyor systems designed for continuous, high-volume processing. They pass through high-pressure wash stations that remove dirt, debris, and residue. Water isn't simply discarded, it's filtered, treated, and reused under strict environmental standards. Cleanliness isn't just about food safety, it protects oil quality in later stages. Next, automated cutters split each avocado in half. Pits are removed and diverted to secondary processes. Only the flesh continues forward. This is where all economic value resides. The flesh enters industrial grinders, where it's processed into a uniform paste. Temperature control here is critical. For cold-pressed avocado oil, heat must stay below a defined threshold to preserve beneficial compounds. Sensors continuously monitor conditions. But data doesn't run the plant. People do. Operators interpret readings, adjust parameters, and intervene when necessary. The paste then enters high-capacity centrifuges. At extreme rotational speeds, oil separates from water and solids. This is the moment the avocado becomes oil. The process is continuous, no batch stops. Tens of tons of avocados are processed every hour in a closed-loop system. Not all oil meets standards. Producing 1 liter of avocado oil requires 8 to 10 kilograms of fresh fruit. Oil that doesn't meet specifications is diverted or discarded. Approved oil passes through multiple filtration stages before resting in massive stainless steel tanks for stabilization. Throughout this process, the facility isn't fully autonomous. Engineers monitor temperature, pressure, flow rates, and stability. One deviation triggers immediate adjustment. Technology enables scale. People ensure control. And here, inside the factory, that balance is most visible. Before bottling, every batch undergoes quality testing: color, aroma, acidity. If it fails, it doesn't reach the market. These aren't just legal requirements, they're industry standards. Because once a product reaches consumers, there's no room for error. Once approved, bottling begins. At this stage, the priority is preservation. Oil flows into high-speed filling lines with near-perfect accuracy. Each bottle is filled precisely, sealed, labeled consistently. Final inspection systems check caps, labels, and fill levels. Defective units are removed instantly. Approved bottles are packed, palletized, and sent into national distribution networks. From factories to logistics centers, then to grocery stores across the country. Few people realize that behind a familiar bottle of avocado oil lies a supply chain stretching from orchard to factory, ending in a product that meets national food standards. From a single flower on a branch to a mature avocado months later. From human hands in orchards to precision-controlled factory systems. The journey of avocado oil is more than a food story. It's a story about time, labor, and how complex systems are organized to create value at scale. In modern agriculture, machines enable production, but people determine quality. Every choice, in the field, in the factory, leaves a mark. If you're curious about how agriculture operates behind everyday products, this channel will continue exploring similar processes across food and farming systems. Stay with us, watch the next videos, and see how the world is fed every single day. In export banana production, harvest timing is not determined by ripeness. It's determined by the fruit's most stable physiological stage. That's why bananas are never harvested when they're ripe. They're picked while still green. At this stage, the banana has already reached its full size. The shape is fully developed, and the sharp edges of the fruit have rounded out. Inside, starch levels remain high, while sugar content is still low. This isn't the best stage for eating, but it is the best stage for long-distance transport. Bananas are a climacteric fruit, meaning they continue to ripen after being harvested. This biological trait allows producers to control ripening using temperature and storage conditions. If bananas were left to ripen on the plant, the flesh would soften quickly, the peel would become fragile, and the fruit would no longer survive weeks of transportation. In reality, an export shipment of bananas must endure a long journey, including inland transport, cold storage, ocean shipping, and distribution at the destination market. This process can take several weeks. For that reason, harvesting bananas while they're still green isn't a preference. It's a requirement to preserve quality and minimize losses throughout the entire supply chain. Once the harvest window is set, cutting a banana bunch becomes a precise operation, not a simple manual task. On export banana farms, each bunch is always harvested by 2 workers, never just one. A mature banana bunch can weigh anywhere from 40 to 80 pounds. Its weight, combined with the fruit's soft structure, makes the process inherently risky if done incorrectly. Each worker has a clearly defined role. The first worker positions himself close to the bunch, supporting its full weight with his arms and body. His responsibility is to control movement and prevent the bunch from swinging or falling. The second worker stands behind the plant and uses a sharp blade to cut the banana stem at a calculated angle. As the plant collapses, the entire weight of the bunch is already secured by the first worker. Any mistake at this stage has consequences. A fall, a minor impact with the ground, or even a small scratch on the peel is enough to disqualify the entire bunch from the fresh export market. In large-scale production, bananas aren't judged by sweetness or flavor. They're judged by surface perfection. That's why cutting the bunch isn't just the start of harvest. It's the first quality checkpoint, where the fate of the fruit can be decided in just a few seconds. Bananas don't leave the field the way most people imagine. They are never dropped on the ground. They are never carried long distances by hand. The moment a banana bunch is cut from the plant, transportation begins almost immediately. On large export banana farms, especially in Ecuador, the fruit is moved using an overhead cable system. This system runs above the plantation, stretching across rows of banana plants like a suspended highway. Each freshly cut bunch is attached to a metal hook and lifted onto a steel cable. From there, gravity does most of the work. With carefully calculated slopes and tension, the bunch glides smoothly along the line, traveling from the harvest point to the central processing area. The movement is continuous and controlled. There is no need for repeated handling, no unnecessary stops, and almost no additional human intervention once the bunch is on the cable. This system offers several critical advantages. First, the bananas never touch the ground, dramatically reducing the risk of contamination. Second, hanging the bunch minimizes vibration and impact, which is essential for fruit that is both heavy and structurally soft. Even minor shocks can damage the peel and compromise export quality. Just as important, the cable system allows bananas to move quickly across large plantations. In operations where thousands of bunches are harvested each day, manual transport would increase damage rates and make consistent quality nearly impossible to maintain. When the bananas reach the collection point, they are carefully removed from the cables and arranged on standardized pallets. Forklifts then load the pallets onto trucks, which transport the fruit directly to the processing facility. At this point, the bananas have left the plantation environment, but the most critical phase of quality control is only beginning. Once the bananas arrive at the packing facility, they are not immediately sorted or boxed. Before anything else can happen, the fruit must go through a fundamental stabilizing process, washing and desaping. Freshly cut bananas continue to release a natural latex-like sap. This sap can stain the peel, promote fungal growth, and significantly reduce the fruit's commercial value. If it is not removed early, even a visually perfect banana can deteriorate during storage and transport. To prevent this, entire bunches are submerged in large water tanks as soon as they enter the facility. The washing process gently removes sap from the surface of the peel, while also rinsing away dirt and debris collected during harvest. The water in these tanks is not ordinary. Its cleanliness, temperature, and composition are closely monitored to ensure effective cleaning without damaging the banana's natural protective layers. The immersion time is carefully controlled, long enough to clean the surface, but short enough to prevent water absorption into the fruit. Beyond removing sap, this step also reduces the microbial load on the banana peel. This is especially important for exporting fruit that will spend weeks in cold storage and ocean transit. A clean, stable surface greatly slows the development of mold and other pathogens during that journey. In many ways, washing and descaling serve as the foundation for everything that follows. If this step is poorly executed, even the most advanced sorting, packing, and refrigeration systems cannot compensate for the damage. It is here, quietly, and often unnoticed, that the banana's quality begins to be controlled according to industrial standards, setting the stage for the decisions that will determine its final destination. This is the moment when every banana is judged. After washing and surface stabilization, bananas enter the most decisive stage of the entire process, sorting. From this point forward, there are no second chances and no exceptions. First, the banana bunches are separated into smaller hands, typically containing 5 to 7 fruits each. This step allows for more precise inspection and aligns with international packing and shipping standards. Each hand is then placed on a slow-moving conveyor belt that carries it through the inspection area. Here, trained workers examine every hand using a strict set of criteria. Size must fall within a narrow range required by export markets. Peel color must be consistent, with no signs of bruising, discoloration, or abnormal spotting. The surface of the peel is checked carefully for scratches, even the smallest ones. Shape also matters. Bananas that are too curved, misshapen, or irregular are immediately flagged. What's important to understand is that this process is not subjective. Every criterion is based on years of production experience, market requirements, and the banana's ability to withstand long-distance transportation. A banana can be perfectly edible on the inside, yet still be rejected if its appearance does not meet export standards. The outcome is clear and final. Hands that meet all requirements move forward toward packing and cold storage. Those who do not are separated immediately. They are not discarded, but they will follow a completely different path. It is at this exact point that the fate of each banana begins to diverge, opening the door to a secondary value chain hidden behind the export industry. Only a fraction of harvested bananas make it past sorting. Those that do represent the highest standard in appearance, size, and uniformity. These bananas are cleared for fresh export, and packing and cold storage become the final gateway they must pass through. Each approved hand is first placed into a protective plastic liner. This layer reduces moisture loss, minimizes friction between fruits, and helps preserve the integrity of the peel during transport. The bananas are then carefully arranged into standardized cardboard boxes, typically weighing between 13 and 18 kilograms. Each box is labeled with traceability information, allowing it to be tracked from the plantation to the destination market. Once packed, the boxes move directly into cold storage facilities, where temperatures are maintained between 13 and 14 degrees Celsius. At this range, the banana's internal biological activity slows dramatically. The ripening process is effectively paused, allowing the fruit to remain in a stable green state for weeks. This cold stage is what makes long ocean voyages possible. Bananas can cross multiple climate zones without ripening prematurely or spoiling. Only after leaving cold storage and entering controlled ethylene environments at destination markets does ripening resume, precisely when retailers need it to. Bananas that do not enter this cold chain never become fresh export fruit. Instead, they are redirected into other processing streams. From here, a different journey begins, one where rejected bananas take on new roles and create value in ways most consumers never see. This is where most people think the story ends. Once sorting is complete, it becomes clear that not every banana is good enough for the fresh export market. But in modern banana production, rejected for export does not mean waste. In fact, this moment marks the beginning of an entirely different value chain. Bananas that fail to meet export standards because of size, shape, or minor surface imperfections are separated immediately inside the facility. From this point forward, they no longer enter the cold chain designed for fresh exports. Instead, they are redirected into specialized processing lines based on their ripeness, physical condition, and intended end use. What looks like rejection is actually optimization. One of the most common processing routes is dried banana production. The raw material for this product typically includes bananas with uneven shapes or minor cosmetic damage to the peel, while the flesh inside remains perfectly suitable for consumption. The bananas are peeled and sliced into uniform pieces to ensure consistent drying. Before dehydration begins, the slices are treated to slow oxidation, helping preserve their natural color and appearance. They are then placed into drying systems operating at moderate temperatures, usually between 55 and 65 degrees Celsius. The drying process lasts several hours, reducing moisture content to a level that significantly extends shelf life without the need for chemical preservatives. The final product is a shelf-stable, dried banana, sometimes crisp, sometimes slightly chewy, packaged and sold as a ready-to-eat snack. Despite originating from fruit rejected for export, these products often carry a higher price per unit weight than fresh bananas. Alongside dried bananas, soft-dried bananas represent a separate category with different processing requirements. These products use bananas at a more advanced stage of ripeness, when natural sugar levels are higher and flavor is more pronounced. Instead of higher heat, the bananas are dried at lower temperatures over a longer period. This slower process allows part of the moisture to remain within the fruit, creating a softer texture while concentrating sweetness. The result is a product that is pliable, rich in flavor, and aligned with consumer demand for minimally processed, energy-dense foods. Soft-dried bananas are often distributed in premium markets, where buyers place a higher value on natural ingredients and nutritional integrity. For green bananas or excess volumes that cannot be absorbed by fresh or snack markets, banana flour offers an efficient alternative. The bananas are peeled, chopped, and dried until all moisture is removed. They are then ground into a fine powder and sifted to achieve uniform particle size. Banana flour is particularly valuable in gluten-free food production. Its high-resistant starch content makes it suitable for baked goods, pasta alternatives, nutritional supplements, and infant foods. Compared to fresh bananas, banana flour has a much longer shelf life and significantly higher economic value per kilogram. At this stage, it becomes clear that export rejection is not the end of the banana's journey. It is simply a transition. Each processing pathway is designed to extract value from the fruit based on its biological state, ensuring that very little of the harvest is truly wasted. Another major processing route is plantain chips. These are typically made from plantains, a starchy banana variety that is lower in sugar and better suited for high heat cooking. Plantains are not intended to be eaten raw as dessert fruit, but they are ideal for large-scale snack production. The plantains are peeled and sliced into thin, uniform pieces. The slices are then fried in hot oil for a short period of time, just long enough to achieve the desired texture. After frying, excess oil is removed, and the chips may be seasoned according to the preferences of different markets. Plantain chips have a long shelf life and are produced in large volumes. They are exported extensively, particularly to North America and Europe, where demand for savory snack foods continues to grow. Not all rejected bananas are suitable for human food processing. Bananas that are overly ripe, physically damaged, or no longer meet food safety requirements are redirected into animal feed production. These bananas are crushed and mixed with other agricultural byproducts. In some cases, the mixture undergoes fermentation to improve digestibility and nutritional availability for livestock. This feed is commonly used for pigs, cattle, and poultry. While the economic value per unit is lower compared to food products for humans, this pathway plays a critical role in utilizing farm biomass efficiently and reducing overall waste. At a more industrial level, severely damaged bananas, peels, and other byproducts can be used to produce bioethanol. In this process, the starches and sugars present in bananas are broken down through hydrolysis and fermented by microorganisms. The resulting liquid is then distilled to extract ethanol. Banana-based bioethanol is used as a renewable energy source or as an industrial input. Although it represents a smaller portion of total banana utilization, it clearly illustrates how modern banana production embraces circular economy principles, where even materials with little apparent value are reintegrated into productive systems. Taken as a whole, the processing pathways for bananas that fail fresh export standards reveal a core principle of modern agriculture: minimizing waste while maximizing value. Each group of bananas, depending on its condition and biological state, is directed toward the most appropriate use. As a result, actual losses across the banana supply chain remain remarkably low. This ability to organize and operate an efficient processing system is a key factor in the long-term sustainability of the export banana industry. Bananas that never appear on supermarket shelves still contribute to the economy, just in forms that most consumers never see. When you step back and look at the full journey of a banana, from hanging on the plant to appearing on store shelves or inside processed products, it becomes clear that nothing happens by accident. Every step is guided by plant biology, market requirements, and the realities of global logistics. Bananas aren't allowed to ripen on the plant because that doesn't serve long-distance transport. Bananas that fail fresh export standards aren't discarded because in modern agriculture, waste is no longer an option. Instead, each banana is directed toward the use that makes the most sense, from food for people to animal feed to renewable energy. What truly makes the difference isn't the banana itself, but how the entire system around it is designed. Discipline, standardization, and optimization have transformed a familiar, inexpensive fruit into a global industry with enormous value. And if you've ever thought of bananas as simple or ordinary, this journey may have revealed a different perspective. If you'd like to keep exploring the hidden systems behind the foods we consume every day, feel free to share your thoughts in the comments and consider following the channel for the next story. Harvesting is the most critical stage in the entire watermelon juice production chain. The quality of the final product is not determined inside the factory. It is already set the moment the watermelon leaves the ground. In major watermelon growing regions of the United States, including Florida, Texas, and California, individual fields can stretch across hundreds of acres. Watermelons are planted in straight rows, protected by ground cover, and grown for weeks under closely monitored conditions. When harvest season arrives, the goal is not speed, it is precision. A watermelon destined for juice production must meet multiple criteria at once. Ripeness is judged by rind color, the yellow field spot where the fruit rested on the soil, and the experience of trained crop inspectors. Sugar content and internal structure are especially important. They directly influence color, flavor, and stability later in processing. Unlike many other crops, watermelons cannot be fully harvested by machines. Their size, weight, irregular shape, and relatively fragile rind make mechanical harvesting unreliable. As a result, most watermelons in the United States are still harvested by hand. Workers cut the stem with specialized knives, then carefully roll each watermelon into collection rows. From there, the fruit is lifted by hand or transferred onto mobile conveyors and fed into the harvesting system. Each watermelon receives a brief inspection to identify cracks, bruises, or uneven development. Harvesting often continues for long hours under high temperatures and strict time pressure. Thousands of watermelons must be collected within a narrow window. Once the fruit leaves the field, natural changes begin immediately. From this moment on, time becomes a decisive factor. The watermelon now moves into the next stage of its journey, leaving the agricultural environment and entering the industrial transportation system, where every passing hour directly affects the quality of the juice yet to be made. Immediately after being cut from the vine, watermelons begin a natural process of change. From this point forward, collection and transportation become critical to preserving raw material quality before industrial processing begins. At large-scale watermelon farms across the United States, collection typically takes place at the same time as harvesting. Along the planting rows, mobile conveyor systems are positioned to receive watermelons as soon as workers finish cutting the stems. Each fruit is placed onto the conveyor and moves steadily toward the harvesting vehicle, creating a continuous flow of raw material leaving the field. In areas where conveyors are not used, watermelons are passed by hand from worker to worker. This method allows greater control over physical impact and enables early detection of damaged fruit. Regardless of the method, the objective is the same: to minimize shocks and mechanical stress during handling. Sorting continues at this stage. Watermelons showing cracks, bruises, or irregular shapes are removed directly in the field. Early removal reduces transportation costs and prevents lower quality fruit from entering later stages of processing. Watermelons that meet standards are loaded onto harvesting vehicles or transport trucks. These vehicles are designed to distribute weight evenly, reducing prolonged pressure on the fruit. Once the trucks leave the field, transportation schedules are tightly controlled. For watermelons destined for juice production, the time between harvest and arrival at the processing plant typically does not exceed 24 hours. This narrow window helps preserve pressing efficiency and ensures the final juice maintains its color, flavor, and overall quality. Transport vehicles typically travel directly from the farm to the processing facility according to pre-planned schedules. In large-scale juice production operations, raw material intake must be precisely synchronized with the processing capacity of the production line. Arriving too early or too late can disrupt workflow and affect overall system efficiency. During transport, watermelons are not deeply refrigerated, but the temperature inside the truck must remain stable. The goal is to prevent heat buildup and slow natural reactions that could alter the structure of the flesh. Proper ventilation helps maintain safe transport conditions until the fruit reaches the receiving area. Upon arrival at the plant, watermelons are not immediately processed. Instead, they are transferred to the raw material receiving zone, where each load undergoes a rapid inspection. Technicians assess overall uniformity, surface condition, and compliance with juice production standards. Any fruit that fails to meet requirements is removed, even if it has passed previous screening stages. Once the receiving process is complete, approved watermelons are placed onto the plant's intake conveyor. From this point onward, processing moves entirely into a controlled environment where machinery, sensors, and specific technical parameters govern each step. Once watermelons enter the plant's processing line, the first operation is always washing and cleaning. This step is not only about sanitation, it forms the foundation for stable and safe operation throughout the rest of the production process. Watermelons are placed onto the intake conveyor, where they move continuously through an automated washing system. This system typically consists of multiple stages, combining clean water with mechanical motion to remove soil, dust, and surface contaminants. Conveyor speed is carefully adjusted to ensure that each watermelon is cleaned evenly. Unlike smaller fruits, watermelons are large and round, which requires washing equipment designed to reach the entire surface without causing abrasions or cracking the rind. Slowly rotating rollers allow the fruit to turn evenly in the water flow while minimizing impact between adjacent watermelons. Water quality is strictly controlled during this stage. The wash water is filtered and refreshed continuously to prevent recontamination. In some facilities, sensors are used to monitor water parameters in real time, ensuring food safety standards remain within approved limits. Beyond sanitation, washing also serves as the final preliminary inspection point. Small cracks or surface damage become more visible as the fruit passes through the washing system, and any compromised watermelons are removed before cutting. This early removal helps prevent cross-contamination further down the line. Once cleaning is complete, the watermelons exit the washing area with a clean, uniform surface. At this point, they are fully prepared for the next stage of processing, where the outer rind will be removed and the edible flesh will transform. After washing, watermelons move directly into the cutting and rind removal area. This is the first stage where the flesh of the fruit is handled directly, and it marks the most visible transition from whole fruit to processed raw material. The watermelons travel along the conveyor at carefully controlled spacing to prevent collisions. At the cutting station, industrial blades are arranged to process each fruit in a fixed sequence. Depending on the facility's design, the cutting system may operate fully automatically or with operator oversight to ensure precise cuts. The goal of this stage is not only to remove the tough outer rind, but also to preserve as much usable flesh as possible. The green rind and the white layer beneath it, both unsuitable for juice extraction, are removed immediately and separated from the main production line. Eliminating these non-essential parts early reduces downstream load and improves pressing efficiency. Quality control continues throughout the cutting process. Watermelons showing internal defects, such as uneven texture or inconsistent color, are identified and removed before reaching the next stage. This is especially critical in juice production, where raw material uniformity directly affects color, flavor, and batch consistency. After rind removal, the watermelon flesh is cut into blocks or chunks sized specifically for the pressing system. These dimensions are not arbitrary. They are calculated to ensure a continuous flow into the presses while preventing clogging or uneven distribution. At this point, the pace of the production line increases noticeably. Hundreds, sometimes thousands, of watermelons are processed every hour, creating a steady stream of bright red flesh moving through the plant's controlled environment. After the cutting and rind removal stage is complete, the watermelon flesh is transferred directly to the pressing area. At this point, the most critical transformation in the entire production line begins. The objective of pressing is to extract as much liquid as possible from the flesh while preserving the watermelon's natural color, flavor, and characteristics. The uniformly sized watermelon pieces are fed continuously into the pressing system. Industrial presses are designed to handle high volumes of material in a short amount of time while maintaining stable pressure levels. Pressure control is essential. Excessive force can draw unwanted solids into the juice, while insufficient pressure reduces extraction efficiency. As the watermelon flesh passes through the press chamber, the cellular structure breaks down, releasing the liquid contained within. The first stream of juice emerges with its distinctive bright red color, offering an immediate visual indication of raw material quality. At this stage, any inconsistencies originating from earlier steps, such as harvesting, handling, or cutting, become clearly visible through variations in color and uniformity. During pressing, the system continuously separates solid pulp from the liquid fraction. The solid residue is diverted away from the main production line for separate handling, while the juice moves forward to the next processing stages. Effective pulp separation at this point reduces the load on downstream filtration systems and improves overall product stability. Pressing speed is carefully adjusted to match the plant's total processing capacity. Interruptions in material flow are avoided, as fluctuations can alter pressure conditions and negatively affect juice quality. For this reason, the pressing area is often considered the operational core of the entire facility. Throughout the process, key technical parameters, including pressure, temperature, and flow rate, are monitored continuously. The goal is not only to maximize juice yield, but also to ensure that the watermelon's natural properties remain intact throughout mechanical processing. After pressing, the extracted watermelon juice is still considered raw juice. Although most of the solid pulp has already been removed during pressing, the liquid still contains fine fibers, small particles, and other unwanted components. The filtration and stabilization stage is designed to address these remaining elements with precision. The raw juice is directed into a filtration system, where mechanical filters operate continuously. Depending on the specifications of the final product, the plant may use multiple filtration stages, ranging from coarse to fine filtration. The objective is to remove residual solids while preserving the watermelon's natural color and flavor. During filtration, flow rate and pressure are tightly controlled. If the juice moves too quickly, filtration efficiency decreases. If it moves too slowly, overall line productivity can be compromised. For this reason, these parameters are constantly adjusted to maintain a balance between quality and throughput. Alongside filtration, the juice undergoes stabilization. At this stage, factors such as uniformity, color consistency, and liquid structure are monitored and fine-tuned. The purpose of stabilization is to ensure that every batch of juice exhibits the same characteristics, regardless of minor variations in the incoming raw material. Temperature is maintained within a controlled range to limit unwanted changes and to prepare the juice for subsequent processing steps. Any deviations in color or aroma become especially noticeable at this point, allowing the plant to make timely adjustments before the product moves further down the line. Once the juice exits the filtration and stabilization system, it has reached a mechanically clean and uniform state. The liquid now displays a stable, characteristic red color and is ready for the next stage, where it will be filled, sealed, and transformed from a raw ingredient into a finished commercial product. After filtration and stabilization are complete, the watermelon juice moves into the bottling stage. From this point forward, the product is no longer considered a semi-processed ingredient. It begins to take its final form for market distribution. The juice is fed into an automated filling system, where filling nozzles operate in sync with the conveyor line. Each bottle is positioned precisely before being filled with an exact volume of juice according to predefined specifications. Accurate fill levels are critical, as even minor deviations can affect product consistency and commercial compliance. Throughout the filling process, flow rate and pressure are carefully regulated to ensure the juice flows smoothly without foaming or disrupting its liquid structure. This is especially important for visually sensitive products like watermelon juice, where any disturbance can affect appearance and perceived quality. Immediately after filling, bottles move into the capping stage. Caps are applied automatically and tightened with calibrated force to ensure a proper seal without deforming the bottle. This step protects the juice from external contamination and helps maintain quality throughout distribution. Once capped, the bottles pass through a rapid inspection zone. Sensors, or quality control personnel, identify bottles with incorrect fill levels, improper seals, or other irregularities. Any bottle that fails inspection is removed from the line immediately. After leaving the bottling line, the filled bottles are transferred to the case packing area. At this stage, the production process shifts from food processing to internal logistics, with the primary goal of protecting the product and preparing it for large-scale transport. The bottles are automatically grouped into fixed configurations and placed into cardboard cartons or plastic trays, depending on distribution requirements. The case packing system operates in synchronization with conveyor speed, ensuring bottles are positioned correctly and minimizing the risk of impact or tipping during loading. Once filled, cases are sealed using adhesive or mechanical locking systems to secure the contents. Cases that fail to meet shape or sealing standards are rejected at this point. Approved cases continue to the palletizing area, where they are stacked according to predefined patterns designed to optimize space usage and maintain stability during movement. Finished pallets are wrapped with stretch film, securing the load and preparing it for outbound transportation beyond the facility. Once secured on pallets, the watermelon juice shipments are transferred to the plant's shipping area. At this point, the product leaves the production line and enters the distribution network. Pallets are loaded onto trucks or containers according to pre-planned schedules. Forklifts are used to minimize vibration and ensure load stability throughout the process. Before departure, shipment details and destination information are checked one final time to maintain alignment between production and distribution. During transportation, both temperature conditions and transit time are managed to help preserve product quality. From the factory, the juice is delivered to distribution centers and retail systems, where it officially enters the consumer market. At this stage, the journey of the watermelon is complete, from an agricultural field to a commercial product ready for consumption. The journey may end here, but similar processes are taking place behind every agricultural product we use every day. If you're interested in how food is grown, harvested, and processed at an industrial scale, explore more videos on this channel. And if you found this process informative, consider subscribing so you don't miss the next one.